So let's talk about one of the great head-scratchers in the history of science, a guy named Max Planck. Here was a man whose entire personality was cautious, conservative, traditional. And yet, he's the one who ended up kicking off a scientific revolution that completely turned physics on its head. You know, this quote from his colleague, Max Born, just absolutely nails it. Planck wasn't a revolutionary because he wanted to be. No way. He was a revolutionary because the facts, the evidence, they backed him into a corner. And his respect for logic was so strong that it forced him to break with everything he thought he knew. All right, so to really get why Planck's big idea was such a bombshell, you have to picture the world he was living in back in the late 1800s. The feeling among physicists at the time was, well, that they were pretty much done. They figured they'd answered all the big questions. All that was left was just to dot the I's and cross the T's. I mean, listen to this. This is literally what Max Planck's own professor told him when he was a student. He advised him not to go into physics, basically saying, look, it's a great field, but you kind of miss the party. Everything important has already been discovered. Can you imagine? And Planck's own upbringing totally reinforced this conservative, everything is settled kind of view. He came from this long line of academics, judges, people who valued order, tradition, and established rules. So he wasn't a natural boat rocker. He loved the beautiful clockwork perfection of classical physics. But there was a problem. In that beautiful, perfect world of 19th century physics, there was this one tiny, little, incredibly annoying crack in the wall. A puzzle that just refused to be solved. And it was called the black body radiation problem. Okay, so what in the world is a black body? Just think of a perfect oven with a tiny little peephole. When you heat it up, it starts to glow, right? First red, then white, then blue. Well, physicists wanted one single, beautiful equation that could predict the exact color, the frequency, of that glow at any temperature. Sounds simple enough, but it turned out to be a nightmare. And this is where it all started to fall apart. See, they had two different theories, and each one was kind of right, but also spectacularly wrong. One theory, Wien's law, worked perfectly for high frequencies, like ultraviolet light, but it completely failed at low frequencies. The other one, the Rayleigh-Jeans law, was the exact opposite. It worked great for low frequencies, but when you pushed it towards the high end, it predicted that the object should be blasting out an infinite amount of energy. They called this the ultraviolet catastrophe, and it was just impossible. Physics was broken. So Planck was completely stuck. All the rules he trusted, all the physics he'd built his career on were failing. After years of banging his head against this wall, he decided to try something that went against every fiber of his being. And this wasn't some triumphant eureka moment for him. Not at all. He said it himself. It was an act of despair. He wasn't setting out to start a revolution. He was just a guy desperately trying to get the math to work, even if it meant throwing out everything he believed in. And this is it, the idea that changed everything. Planck suggested, what if? What if energy isn't a smooth, continuous river? What if it's more like a stream of tiny individual packets? He called these packets quanta, and he said the energy of each little packet was equal to its frequency, nu, multiplied by a brand new, fundamental number of the universe, which he called h, now known as the Planck constant. But get this, even after his formula worked perfectly, Planck himself didn't really buy it. He thought of it as just a weird mathematical trick, a purely formal assumption that somehow gave him the right answer. He had absolutely no idea that he'd just accidentally discovered the fundamental graininess of reality and laid the first stone for all of quantum mechanics. Now, while Planck's crazy idea was starting to rewrite the rules of science, his own personal life was just shattered. He went through a series of almost unbelievable tragedies, all while Germany was descending into war and political horror. So in 1918, he gets the phone call. He's won the Nobel Prize. It's the absolute peak of a scientist's career. But for him, this incredible professional high came during a time of the most profound personal lows. I mean, just look at this timeline. The scale of his personal suffering is just staggering. He lost his first wife. His oldest son was killed in World War I. Both of his daughters died in childbirth within 2 years of each other. And then his last son, Irvin, was executed by the Nazis for being part of the plot to assassinate Hitler. He outlived all of his children. It's just unimaginable. And yet, through all this, he showed incredible courage. In 1933, he actually got a meeting with Adolf Hitler. He went there to personally argue against firing Jewish scientists, telling Hitler it would destroy German science. Well, Hitler reportedly flew into a rage, and Planck's plea went nowhere. It was a failed attempt, but an unbelievably brave one. So, when you look back at it all, what is his legacy? How did this reluctant revolutionary, this man who endured so much, feel about the bizarre new world that he himself had helped create? Well, here's the final, incredible irony of his life. Max Planck never really got on board with quantum mechanics. As the next generation of physicists, guys like Heisenberg and Bohr, started exploring the truly weird implications of his idea, with its randomness and uncertainty, Planck hated it. He always hoped it was just some temporary workaround, and that someday physics would get back to the old, predictable, certain world he loved. And that brings us to maybe his most famous quote. It's so powerful because, in a way, he was talking about himself. He had been the young guy with the radical idea that the old guard couldn't accept, but by the end of his life, he had become the old guard, uncomfortable with where the new generation was taking his own work. He saw the process of scientific change from both sides. But make no mistake, his legacy is absolutely everywhere. That number h, the Planck constant, it's now understood to be one of the fundamental constants of the entire universe. The Planck units he defined are still used to explore the very limits of reality. And the most prestigious scientific organization in all of Germany is now called the Max Planck Society in his honor. You know, the story of Max Planck really makes you think. Here was a truly brilliant mind, a pillar of physics, who was held back by his own worldview, never quite able to embrace the revolution that he himself started. It really begs the question, doesn't it? What huge, world-changing ideas might be staring us in the face right now that we're just too reluctant, too set in our ways to fully accept?